Okay, so here is yet another example. And this one we have a ball and socket supported A, as well as a force in the cable. And again, a ball and socket is what we did today in class when we talked about the ball and socket. It is like your hip, or maybe like your shoulder. Your hip, you have at the end of your femur, you have a ball that fits into your pelvic girdle like a socket. And when the ball is fitted into the socket, then we can rotate this all around. I could spin it within there, okay? So like torsion, I could spin it, it's going to spin. I could rotate it any which way I wanted. But if I try to pull this into the X direction, that ball is fitted down into the socket, it's not going to go anywhere. So it can rotate around, but I can't pull it. So I'm developing a force in the X direction. If I try to pull it, like grasp it and pull it in the Y direction, it's going to stay right there in that socket, so I'm developing a force in the Y. If I grab it and try to pull it up, that ball is down in that socket, so the only thing that's coming out would be the shaft right here, okay? So I am developing a force in the X direction, but if you take your hip, you can rotate it all around, okay? You can rotate your hip. You can rotate your shoulder. I'm trying to get this to focus. I'm having issues tonight. And your hip can rotate all around, but we can't just pull your leg off. Okay? Of course, your hip has muscles and tendons and things, but I don't think I have an example of a ball and socket. It would be awesome if I did. Someday I should buy little tiny reactions to show you all. But just imagine it's kind of like this. The ball is inside. You can't pull the ball out, but there's room for it to rotate and move around. And then we have this tension cable. And with a tension cable, I can cut it wherever I want. So I'm going to cut it right here and show it as a positive, okay? Because I'm in equilibrium. So I'm going to go ahead and deal with these up here. I can see that I have 5 kilonewtons. It is pulling in this Y-X plane. And so it's going to have an X component and a Y component. So is opposite. Ca is adjacent. So I have 5 cosine 30 and 5 sine 30. If I look back here, again, we're in this XY plane. And I'm going to have an X component and a Y component. So I have 5 so ca cosine 30. And I have 5 sine 30 going in the negative direction. So let's see if we can get this drawn. And I have my X, I have my Y, okay, and I have this little nub coming out, and I have my tension cable coming out and then heading straight down to the Y-axis. So I can call this tension, and we're just going to call it tension B because it lines at B. And this distance is 1.5 meters. Okay. I can also see that I have a 5 cosine 30 and a 5 cosine 30. And then I've got 2 times 5 sine 30. So this is my free body diagram. This is 2 meters up and 3 meters up. So I didn't do a very good job of drawing that to scale. Okay. So what unknowns do we have? We have an unknown X. We have an unknown Y, we have an unknown Z, we have an unknown tension. So I need to make sure I get these. So I have AX, AY, AZ. And remember, we show everything in the positive direction when we're looking at these types of reactions. So now we can start. Let's sum forces in the X direction, except X is coming out of the page with 3D. X direction. Okay, so I have AX, plus 5 cosine 30 minus 5 cosine 30 equals 0. These cancel out, so AX equals 0. Okay, now we're going to sum forces in the y direction. Positive equals 0, and I have AY minus 2 times 5 sine 30 equals 0. AY equals 10 sine 30. AY equals 5 kilonewtons, because that's going to be 0.5. Half of 10 is 5, so 5 kilonewtons. Okay, if we sum forces in the z direction, up is positive. I have this unknown AZ. I don't have any applied, but now I have minus tension of B equals 0. So I have 2 unknowns and 1 equation, and now I'm going to have to look at summing moments. So if we look at summing the moments about about the x-axis, I can see that this tension cable is indeed going to cause a moment about the x-axis. None of these forces cause a moment. These x components are parallel to the x-axis, but this is pulling backwards, so it will also cause a moment about the x-axis. Okay? And that's kind of nice because it gets rid of AZ. So let's sum the moments about the x-axis. Right hand rule positive, thumb coming out of the page positively, wrapping to the back. Okay, so if I look at TB, it is going to be wrapping this way, which is negative. So I have negative TB times 1.5 meter. Okay, and then I'm going to have positive plus 2 times 5 sine 30. Okay, and it has a perpendicular distance of 5 meters. All of this equals 0. So I can say 1.5 TB equals, we're going to move that over to get rid of the negative sign. Well, sine 30 is 0.5. 10 times 0.5 is 5. So I have 5 kilonewtons times 5 meters. 1.5 TB equals 25 kilonewton meters, and TB equals, well, that's roughly 24. 1.5 is 8, 16, 24, so it's going to be like 16 point something, 67 kilonewtons. And now I can plug this back into, and I'm going to get that AZ also equals 16.67 kilonewtons positive, which makes sense. AZ I said going up, TB coming down. So there are my 4 reactions.